friends. Today we are going to discuss ordinary differential equations. But before we dive into ordinary differential equations, let us first see what are differential equations. Differential equations is basically any equation that contains derivatives. For example, dy by dx plus y is equal to 0. So we all know dy by dx is the derivative of y with respect to x. Let us take another example. D square y by dx square is equal to e to the power 2x. This is also a differential equation. Another example would be y dash is equal to sine x. Let us see one more example. Y dash y triple dash minus 3 by 2 y dash square is equal to 0. Look at this equation where y dash is basically dy by dx, or first order derivative of y with respect to x. Y triple dash is nothing but d cube y by dx cube, that is the third order derivative of y with respect to x, and so on. These all are differential equations, but what do they mean? So, a differential equation is anything that involves rate of change of velocity, rate of change of acceleration, rate of change of time, distance, chemical reactions, anything you take from Big Bang theory to chemical reactions to pendulums to fluid mechanics, everything is covered by differential equations. You take any real world problem, convert it into a mathematical one, then what do? Solve the mathematical problem and interpret that solution, mathematical solution, to solve a real world problem. That is why we need differential equations. There are two types of differential equations: ordinary differential equations and partial differential equations. Ordinary differential equations are the ones which have only one independent variable. For example, dy by dx is equal to sine x, where x is the independent variable, y is the dependent variable. It can include higher orders of derivatives also, but only one independent variable. However, in partial differential equations, there can be more than one independent variable. For example, del square u by del x square plus del square u by del y square is equal to 0. Here, the u is a function of x and y. Let us look at the formal definition of ordinary differential equations. An ODE is an equation that contains one or several derivatives of an unknown function, where y is an unknown function, x is the independent variable. Let us discuss some more examples. Sin x cross y double dash 2x minus y is equal to 0. This is also an ordinary differential equation. Now, let us discuss the order and degree of differential equations. The order of any differential equation is the highest order of the derivative of the unknown function. For example, d square y by dx square plus d cube y by dx cube plus y is equal to sine x. Here, the order of the differential equation would be 3, because the highest order derivative of this ordinary differential equation is 3. So the order of the differential equation would be 3. The degree of this differential equation would also depend on the highest order derivative. The power of this highest order derivative is 1. That is why the degree of this differential equation would be 1. I hope you have understood. If not, you can drop a comment in the comment section if you have any doubt. Let us move on to the implicit and the explicit forms of the first order differential equations. First order differential equations would be the equations with the only first order derivative of the independent variable. That is, the equation would include only dy by dx, y, and x. The general form of the ordinary first order differential equation would be f y dash y and x is equal to 0. This is also known as the implicit form, whereas the explicit form would be y dash equals f of x comma y. Let us consider x to the power minus q y dash minus 4y square is equal to 0, where x is not equal to 0. As you can clearly see, this is a first order differential equation in implicit form. Now, to convert into explicit form, what we would do is we would write x to the minus y prime is equal to 4y square, which can also be written as y prime is equal to 4 by x minus 3, or we can say 4x cube y square. This is the explicit form of the differential equation. Let us stop at that. Why don't you go and look at some differential equations, try to figure out their order, their degree, whether they're implicit, or if they're not, try to convert them into explicit form, and so on. And if you have any other problem, you can drop a comment in the comment section, and don't forget to subscribe, like, share, and comment to my video. This is my first video. Hope you like it. Thank you.